2016 Civil Engineering Set 2 Question 51. A noise meter located at a distance of 30 meter from a point source recorded 74 decibels. The reading at a distance of 60 meter from the point source would be. The relevant NPTEL reference has been mentioned. So when we talk about sound pressure level of a noise source, we use the following formula for calculating the loudness of the sound, that is 20 log 10 P by P naught. Here P is the RMS, root mean square pressure level. So we know that P is proportional to the square root of intensity. So substituting this value in terms of intensity, we will get 20 log 10 root over of I divided by root over of I naught. This would turn out to be 10 log 10 I by I naught. So the following two equations exist, one in terms of pressure and the another one in terms of intensity. Another thing that should be noted is intensity is the wattage of the sound source divided by the unit area of the effect. So let us say this is a sound source and we want to calculate its effect at a distance of R, so that would be wattage divided by the whole sphere area that the sound would spread in. So that would be 4 pi R square. In this case we have been given the loudness level at a distance of 30 meters as 74 decibels. The distance corresponding to this is 30 meter from the sound source. The loudness corresponding to 60 meter needs to be found when the separation has been increased to 60 meters. So using the equation L equals 10 log 10 I by I naught. Let us call the intensity in case of R of 30 meter as I30. So this would become 10 into log 10, using the formula of log 10 A by B equals log of A minus log of B to solve this problem. That would be log 10 I30 minus log 10 I naught. This would be 74 decibels. This is our first equation. Secondly, we should know that when intensity is being measured at a distance of 30 meter and when it is being measured at a distance of 60 meter, what will be the relation between the two intensities? So intensity at 30 can be written as 4 pi 30 square, and when it is being measured at 60 it can be written as 4 pi 60 square. So taking the ratio, we would get 60 square divided by 30 square, that would be 4. So when we are measuring the intensity of a sound source at a distance of 60 meters, the intensity would be 1/4 of the intensity when it is being measured at 30 meters. So let us call that loudness level as L dash. That would be 10 log 10 I60 divided by I naught. Expanding this, we would get 10 log 10 I of 60 minus log 10 I naught. Using the relation here, we can express I60 in terms of I30. So that would give 10 log 10 I60 would become I30 by 4. So again we can expand that, log 10 I30 minus log 10 of 4 minus log 10 I naught. So this can be further written as 10 into log 10 I30 minus log 10 of I naught minus 10 times log 10 of 4. So we can see here that this term 10 log 10 I30 minus log 10 I naught is 74 decibels from equation 1. So this can be written as 74 minus log 10 4 into 10. So this would become 74 minus 10 into log of 4 is 0.6. So this would become 68 decibels. So compared to a distance of 30 meter from the sound source, when the loudness level was 74 decibels, when we increased the separation to 60 meter, the loudness became 68 decibels. So it decreased by a value of 6 decibels. So the reading at a distance of 60 meter from the point source would be 68 decibels. The relevant NPTEL reference has been mentioned.